Hop over here. Okay, done. Let's go ahead and share the screen. Start the broadcast. And let's start here. And I'll check the waiting room. I'll just try to be conscious of checking it around 10:15 again. Let me put this back where it needs to be. Okay, now let's see. So as far as announcements, this is what? The end of week 3, right? It's the end of week 3. So what that means is that starting next Wednesday, we can anticipate exam 1 over the first 3 sections. So next week is just devoted to the exam. So I'll probably just show up to take attendance, and I'll just kind of hang around for questions next week. We can kind of like work on stuff in practice, but you'll have access to the exam, and you can ask me. You can even ask questions about the exam if because we're only together for like so many minutes. With all of my assignments, you get unlimited attempts. You can earn up to 100% leading up to the due date, and you can work on any assignment past the due date with only a 10% late penalty. Okay, let me check. Let's see. Today, what I felt like would be apt or appropriate is just to kind of continue working on section 3.1. That's where we left off last time. Let me hit save again because this thing recorded. Section 3. I could do that. That might be easier, maybe not. We'll think about it. So section 3.1 is on exponential functions, okay? So then this is question what, number 13. It comes from section 3.1, question 47. It says that $16,000 is deposited into a bank account paying 5% compounded monthly. What amount would be in the account after 5 years? Let's see, compounded monthly. So this is compound interest, right? Let's see. Let me give myself some space. So let me get a copy of this. Let's see. I go like this. Yeah. Being able to find the tutors. I know several of my classes had like group meets. I think that's a good idea. I encourage it. And you're just finding a way to get this stuff done. So that's and grab this guy. Okay. So it says compounded monthly, right? So we need the compound interest formula. That one, we'll do it in this. We'll do it this way. So P times 1 plus R over N to the power of NT, right? That's the compound interest formula. So then we just fill in the corresponding parts, right? It says what amount will be in there after 5 years. So that means we're trying to find the amount on the account after 5 years, starting with 16,000, right? 1 plus the rate, now 5%, all right? Remember with this formula, we have to write the percent as a decimal. So that needs to be 0.05. If it says compounded monthly, all right, if it says compounded monthly, then that means our N is 12. All right, and then 12 times 5. And then at this point, you just crunch it in the calculator, all right? So then, let's see, let's go with this guy. We can just put 16, 1, 2, 3, parentheses, 1 plus 0.05 divided by 12 to the power of, open parentheses, 12 times 5. Boy, it's going right now, a Barry White. It's just like that. Some mornings. Okay, let's hit enter. We get approximately, if we're talking money, free, and let's go 74 cents. Claire, if you have questions about anything, feel free to unmute yourself and we can talk about it. Or matter of fact, let's just quote this. So now you're doing this thing. $533.74, 20,000 free and 74 cents. Round to the nearest cent. Okay. All right, let's go on to another one. Oh, how much interest will be earned during the 5 years? So then basically say the 16,000 minus this. Let me see, was it 45.33.74? 33. We did was the 20,000 minus the 16,000. The difference was 4,000 with that change. Right. Results from the given interest. It says $70 invested at 8% compounded continuously. So if we're doing continuous compound interest, is A equals PERT, PE to the RT. All right. So I'm gonna see if I can do it here. The P is $70. So we're starting with $70. We're gonna say times E to the power of percent is going to be 0.08 times for 3 years. So it's already 3 years. So we're going to say, this is what we're going to type in the calculator, 70 times E to the power of 0.08 times 3, right? So we're going to do 70 times E to the power of 0.08 times 3. I'll check in like 5 minutes. Let's see. So then we get round to the nearest cent. So 99, 88.99. And this is kind of temperamental. 99. not clear, just you have to stop me. Let's go to the next question. We'll generate the future value of this at 7% compounded annually for 9 years. Okay, let's get a copy of this and pop over. Let's take some notes. So we're gonna get a copy from here. So it says find the principal. It says compounded annually. So we have to use a compound interest formula. Equals P times 1 plus R over, get us R to n to the power of nt, right? Let's plug in what we have. We're trying to solve for P, right? So it says what principal will generate a future value of $12,000. We need to start with. Rate is 7%, so that's going to be 0.07. Compounded annually, so that means our n is 1. Again, n is 1, and the time is 9 years, right? And there's a 1 here. That this is just P times some number, right? Once you crunch this number, this is just P times some number. So if we have some number times P and we want to solve for P, we use the inverse operation of division. So we divide both sides by that number and that'll isolate the P equals, right? So then ultimately P is going to be equal to, let me just copy and paste. $1,000 divided by that number, right? So at this stage, we're going to say 12, 1, 2, 3 divided by, now we have this 1 plus 0.07, that's fine. Power of 9. Oops. Pull up the other part. Right here. Yeah, okay. 2 decimal places. Let me see. Let me check the attendance really quick. So we got 65, 27.20. That's the nearest 21, because they may round it differently. Sometimes they round it differently. Okay, let me check. Oh, we do have one. Go edit. To save. Let's just pull that back up. Record attendance. So that I'm not constantly doing like a lot of back and forth, I might just start taking attendance at the 15-minute mark. I'll probably try it with my later class, because it is a little bit frustrating, like you go back and forth with the attendance a lot. Because I'm using Starfish. Like if I was on my Blackboard, I feel like it would be a lot better. I think the chat is clear. Okay. Okay, let's go to the next question. So find the principal that would generate this amount. Okay, we can actually just use what we just typed into the calculator, right? So because we're solving for the principal, let me see. Future value compounded daily. Yeah, we need to make some changes. Let's see. So I'm gonna try to use what I typed in the calculator before. So now we want to. So our future amount was 13. I mean, is 13 this time? So 13,000. 1 plus R over N. Now our N in this case is daily, so that's 365, right? Last time it was annually, so it was a 1. So this 0.07, I'm going to insert, and we need to divide by 365. Okay. For the exponent, we need to say 365 times. Is it still 9 years? 9 years, so times 9, right? So we just made the necessary adjustments. Okay, let's go with this. Let's give it a go. Because it's the exact same thing with different numbers. Is 69, 24, 11. 69, 24, 11. 13,000. Find the principal, yeah. Future value of that. Oh, okay, we forgot the percent, all right, okay. So let's call that back, second enter, and the percent is 8%, we did 7%. So let's put the 8. 63, 28, 28. We said 63. Change the rate, the initial submission, okay. Let's zoom out some. It's a little bit small. Graph of the function and check the graph of the graphic calculator. Before doing so, describe how the graph of the function can be obtained from the basic exponential function, right? So this is a question on transformations of graphs, right? So if the base function is an exponential function, remember the graph of exponential starts off flat. Essentially, it runs on the top side of the horizontal asymptote being the x-axis, right? So it's nearly flat, and then it passes through the point 0, 1, and then it just takes off exponentially, right? So here we have two transformations at play. There's a little bit different. For something like this, because they did a +3 on the inside, I've seen where you need to factor out that negative. You have to rewrite it first. Matter of fact, let me, I'm going to view an example before I launch into it. Multiply by negative and then +3, right? But it's because it's the inside. Let's look at it. I'm going to see view an example, right? So notice that this one is similar, but they did a -6. Now it says the graph can be obtained, blah, blah, blah. Let's keep going. Yep. So first get the graph of, they subtracted the 6 from the graph here, all right? So that should move it to the right 6 units, right? You see it at the bottom. Then, right 6 units. Then f of -x, so then they introduced their -x, all right, okay. So that's what I need. That's what I needed to see. Bit horizontally over the y. They did the -6 first, and then they introduced the negative, so we can do ours in a similar order, right? So we can start with, if we do x +3, that's going to move it to the left 3. So shift the graph of e to the x, e. So left 3 units, because it's +3, so we're going to go left 3 units. And then reflect, once we introduce the -x, it flips it horizontally over the y, right? So the reason I looked that one up is because of the order, right? Because if you do it in, if you do those in a different order, it'll change the outcome. So I was just trying to get the order perfect. Okay, let's keep going. So then click to graph. So the exponential is, in this case, the bottom left. Like the top right is parabola, the middle left is cubic, the middle right is log, the log function. So exponential, the general shape is the bottom left. Gonna click. The base is E. We said, let's see if we can get this. Go to the right by 3 units, and then flip across the y-axis. I think this is it. Yeah, let's go with this. I hit save and check. Only other thing, again, maybe just change this to a positive 3. That's the only thing I could think. Initially, we said shifted left. I don't think it reflected. Yeah, it totally didn't reflect. Come on. I think we clicked it, but maybe it didn't register. Reflect across the Y. Can we just start over? Clear. Click. Now let me try that one more time, because if we match what we submitted, go left 3. Let me see if I can get that to register first. Okay, and then we flip across the Y. That we could do, we can choose a few test values to test. For instance, when X is 1, we should get like approximately what, 7, right? So E squared. Siri, what's E times E?
80 times 80.
Nope. Hey Siri, stop. Let me pull it up over here. So if we say, I guess we could let's just do this. E, we're just going to choose a few test points. We said when X is 1, so we're going to say to the -1 plus 3, we should get about 7, right? And then for instance, when X is 2, we should get about 3. You get about 3, that's close. And then when X is 3, we should get about 1. Yeah, we get exactly 1, right? When X is 3, okay. Let's just go with that. I don't know what we did different, but anyway, we're just gonna go ahead and submit that. Yeah, okay. So this one's a lot easier because we didn't have that double inside manipulation going on. So exponential, and that +6 is outside our basic function, so it's going to go up 6 units. All right, so that's going to be this one. Click to graph, and we do a vertical shift 6 units up. Really quick. Go here. Stop. Thank you. Oops, not there. This is good. Use transformations to graph. We just did that one. Okay. So what equation represents the asymptote? So the horizontal, that's going to be what? Y equals 6. Y equals 6. So the domain from in a graphical sense is the very left to the very right. So for exponentials in general, the domain is all reals. So we're going to say infinity to positive infinity. bottom to top, this one goes from 6 to infinity. All right, this goes from 6 to infinity. Infinity always gets parentheses. And in this case, again, because 6 is a horizontal asymptote, we actually don't reach. It looks like it touches 6, but it actually doesn't. The whole point of asymptote is that we get infinitesimally close to that asymptote, but we're not going to cross it here. So we never really reach it. So that means the 6 gets a parentheses. It's kind of like Ant-Man from Marvel. You know how he can zoom in and get infinitesimally small. That's essentially what's going on here. If you were Ant-Man, it looks like, from our perspective, it looks like it's touching, but if you were to zoom in, you would see that there's space. There's always space, right? Let's see, in 2001, the median price of a house in a city was $150,000, assuming a rate of increase of 3% per year. What can we expect the price of such a house to be in 2011? Let's see. A rate increase per year. We could do, let's see, is this simple interest? The median price, assuming a rate of 3%, what can we expect the house to be in 2011? Okay. I'm tempted to just do simple interest here. Let me see. Amount. So we can, okay, so we can use give you an example. Yeah, compound interest formula. Okay. So like per A equals PE to the RT. So the future amount is the principal. So I'm just gonna take some notes here. 150, 123 times E to the power of RT. So 3% is 0.03. And then I think this is what, 10 years later. So we're gonna say times 10. All right, that's what we're gonna type in the calculator. Okay, so then here we're gonna have 150, 123, E 3 times 10. All right, or yeah, this one. 278.82. Round to the nearest dollar. So then it's 79. $202,479. Okay, that's what I started to use. I don't know why I hesitated. That's fine. Let's fix that then. That was totally my mistake. Okay. Here, let's write it out here. We need to use a compound interest formula, right? The principal, so that's, what is that? 150, 123 times P times 1 plus R. The rate is 0.03 over N. I think it's compounded, let me see, once per year to the power of NT, so to the power of 10 years, because the compounding is once a year, and this is 10 years later. Let's do this one instead. Oh, how much time do we got? Solid 10 minutes. My headphones are about to lose power. Okay, so let's do this. 150, 123, parentheses 1 plus 0.03 of 10. I think I can just type it like this. It's not a right here, 10. We get, I forgot what we got before. What can we expect? Okay, 2011. Let's go with this. 1,587. Let that be, and go on to the next one. In 1628, an explorer convinced a group of indigenous people to sell him an island for $24. The indigenous people had put that $24 into a bank. If they're indigenous people, will they even know about a bank? Like, what's the context of this? This doesn't make any sense. The indigenous people have put the $24 into a bank account paying 6%. How much would the investment be worth in the year 2002 if the interest were compounded quarterly and continuously? Okay. Yeah, I was review some click the icon to view some finance formulas. I think we got this because now we know like the number of compoundings. Let's get a copy. I need to take some notes. So this is for here. Feature they used to auto fit. Like they keep changing the features, and most of them are like this one is kind of irking me a little bit, but that's okay. Okay, so for instance, for part A, if it says quarterly, that means we're using the compound interest formula. So that one would be A of t, p times 1 plus r over n to the power of nt, right? So we want the future amount. Now, if we're talking the year 2002 and see 1702, what would that be? 17, 18, 19. Equal to, here, let's just do this off to the side. 2 minus 1628. That's 9, that's 9, and that's a 12. 473. Okay, I was almost there. So we want the amount in the account after 374 years, right? Amount was $24. 1 plus the rate, 6%. That's still a good rate. Like, nobody's gonna give them 6%. I mean, if they got $24, but maybe I don't know. It's whatever. This is just a silly question to me. The rate is 6%, so that's going to be 0.06. The n, if quarterly, so that's 4 times in a year, and then power of 374. Oh, that's not a 4. Battery's getting low, but I think we can get up. Times 1 plus 4 times 370, 10 to the 11. Let's see. So you got this. There's a 1304. Oh, 864176. 176. Okay. Then we got, let me see. It's 11, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need like 2 zeros. But 1,000, million, billion, 113 billion, 880, 113 billion, 86,417,600, right? Approximately. It's an approximate. Okay. Let's actually go ahead and do the other one as well before we submit this one. What's the time? Okay. And then for part B, if it says compounded continuously, so that's going to be PERT A of t equals P e to the RT. You see the PERT, right? So then it's going to be A of 374 e to the power of 6. We get 24 e is 74. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then 2 more zeros. Okay. 91,681,300. Okay. Then let's paste. And this one. When I float it. So for the first one, it looks like we got D, right? 113,086, 417, 600, right? So that's fine. We're gonna go with this one and check. Well, we got 133. So that looks like what B? 130, 591, 681, 294. Okay. Let me see the time. All right. Okay, so I don't mind stopping there. I know that there was one request. Someone had a question. Let me see. So the main thing is, so we have exam 1 that'll become available next Wednesday. Yeah, I think you know what to do. Okay. I'm gonna go ahead. All right. Are there any burning questions before we kind of go our separate ways? Again, all the stuff that you see me write, I do make a copy of it available on our Blackboard page. And if there aren't any burning questions, I'm going to end the live stream here. And from one beautiful mind to another, enjoy the rest of your weekend, guys. Okay, take care. Peace.